Hi, I'm Brian Crew, tutoring high school physics. Today's topic, Newton's laws. So, Newton has 3 laws that you'll probably need to have memorized, and you'll have to recite on tests and stuff. So, here they are. First up, an object in motion stays in motion, and an object at rest stays at rest, unless acted on by an outside force. So this unless applies to both of these statements. Okay, so you're probably familiar with the object at rest. You have a box and it's sitting on the floor. It's not going to move. It's going to stay at rest unless somebody moves it, unless they apply a force to the box. But what about objects in motion? Well, most of the objects in motion you see will start going and then they'll slow down and slow to a stop. What's going on there? That violates this law that says an object in motion will stay in motion unless it's acted on by an outside force. Well, here on Earth, there's always going to be an outside force acting on it, known as friction. Whenever an object is moving and is in contact with something else, there's going to be a frictional force, and friction always opposes motion. So, if you have an object in motion on Earth, it'll have a frictional force on it opposing the motion, causing it to slow down. However, if you have the same object in space, where it wouldn't be in contact with anything and so have no friction, it would just keep on going and going and going, staying in motion until something acted on it, some outside force. Okay, so that's the first law. Second law, force equals mass times acceleration. For this particular equation, you're going to want mass in kilograms and acceleration in meters per second squared. So let's say you have somebody, and he weighs 82 kilograms, and he's on Earth, so he experiences a gravitational acceleration of 10 meters per second squared. What is the force of gravity on him? Well, you simply multiply the two together, and you get 820 kilograms times meters per second squared. Now, this particular unit, kilograms times meters per second squared, is also known as a Newton, represented by a capital N. So just switch that out with Newtons whenever you see it. Okay, and the last law. For every action, that is a force that A is applying to B, some object A on some object B, there's an equal and opposite reaction that B is going to apply to A. So those two forces, the action and the equal and opposite reaction, do not happen on the same object. This is wrong. However, if you say this is A and this is B, A exerts a force on B, it feels a force in this direction, and B will also exert a force on A, equal and opposite in the opposite direction. So if you want to think about this in terms of your life, let's say that you're throwing a ball. You might not realize, but the ball is exerting a force on you just as you were exerting a force on the ball. But the force is so small that you're not really experiencing it. So if you do want to experience that force, and just make sure that what I'm saying is true, we're going to switch places. This time you be the ball, and have something else be you. So you're going to just be yourself, and go push on a wall. The wall is essentially you. It is so massive that it's not really going to feel the force that you're exerting on it, so you won't see it move, although it might just a little bit depending on how strong you are. However, you're going to feel the reactive force on yourself, pushing you backwards. Alright, to recap. An object in motion stays in motion, and an object at rest will stay at rest, unless either of those things is going to be acted on by an outside force. So objects that aren't moving will not move unless something else puts a force on them, and objects that are moving will stay moving unless the force is exerting on them. On Earth, this will typically be friction, which always opposes motion. Second law, force equals mass times acceleration. Mass in kilograms, acceleration in meters per second squared, and the unit kilograms times meters per second squared is also known as a Newton, represented by a capital N. Finally, for every action, some object A on some object B, there is an equal and opposite reaction that is some object B acting on that same object A. Alright, that's all for now. Again, I'm Brian Crew. See you next time.